Okay, this guidance for the homework is really just an extension of what we did for conditional probability. You first draw the diagram. I have it slightly different here. I have, instead of P positive and not P, I have N for not P, which is the same, right? Negative is the same as not positive. So it splits into two sides, D, drug user, and not D. If you know that 20% of the players are using drugs, that means 80% are not. And then for each of those groups, they can either test positive or negative, and the numbers here are just read off of that. So you should be able to do this by now. This is just basically what we've been doing before. The second part, number two, what's the expected value? Oh, sorry. The first part, these calculations, that's what we've already done for the midterm. So what we're doing is we're building upon the first midterm and then getting to expected value. So when you calculate the probability of D given P, remember it's using base, it's the first times the flip, which is P given D. So given D, here's P, and then the same plus not D, which is there, and then flip it, P given not D, which is this right here, and that ends up being 78%. And then when you do the other one, instead of negative, it's the same as not P, right? Not positive. You get 99%. So one's a really good test. The other one, sorry, one's a really good test. The other one, not bad, but not great. Um, as for two, now you do the expected value. So you take the expected value, it's the probability of each consequence times the utility of each. So I factored it out. It's the probability of, given that they test negative, what's the chances that they're not a drug user? That's what you really want to know. If they test negative, is that a true negative? Are they really not drug users? So then you multiply that by 100. The points might be in the millions, right? 100 points represents $100 million. I mean, if this is pro baseball, we're talking big money here, right? And then plus P not D given N times 50 plus 20. I just factored out here. That ends up equaling 168. Okay? Now, so the idea here is the expected value. I'm just doing a sketch here. You guys can fill in the rest. Expected value of buying that, right? Given that they test negative, the action of buying these players, given that they test negative, is 168, whatever that means. It might be 168 million overall, whatever. So that's a positive value. Number three, now, given that they test positive, you want to know what are the chances that they are in fact drug users. So given that they test positive, are they really drug users? So now let's look at the expected value. Well, in that case, you take a hit for each of these, maybe because you pay them out of contract and they're costing the organization so much in terms of money or shame or cover up or actual missing of games for suspension. So this is your calculation. You're the guy in the back room determining whether or not to acquire these players based on their reputation, their past behavior, and their reputed use of drugs, and whether or not they'll be caught. And you determine that that value is negative 109. So this is maybe, if we're talking millions, maybe billions, who knows, right? Just a lot. So it's minus 109. Now you want to know the total expected value. So the idea here is aggregate positives. So this is one expected value for the positives only. And then on the flip side, the cons, the negatives. And now we've got two expected values put together. The total expected value is 168 plus negative 109, ends up being 59. So according to this calculation, it's still worth it acquiring these three players. They still have positive overall expected value. Okay. Um, Basically, I've just given the explanation, but the idea here is that expected value, once again, gives you a weighted average of pros and cons of an action. And this is just one example that builds off of what we did with conditional probability. We'll be moving on from here on out.